Good day everyone. You have learnt already how to integrate proper rational functions using partial fraction method. You have learned 3 models in that, right? Now today we will learn how to integrate improper rational functions using partial fractions. What is an improper rational function? Do you remember? The degree of the numerator will be equal or greater than that of the denominator. Now let us see the first example. I is equal to integral x squared plus x minus 1 by x squared plus x minus 6. Here the degree of the numerator is the same as the degree of the denominator. So this is an improper rational function. But definitely the denominator will be factorizable. Okay. So now here the first step you have to do is divide, that is the actual division. You will be dividing the numerator by the denominator. Then you will express it as quotient plus remainder by divisor. Here you should remember the remainder should be at least 1 degree less than the divisor. The divisor is nothing but the denominator. Okay. So now let us start the division. You write the numerator here, that is your dividend. You write the denominator here, that will be the divisor. Now first term by first term, x squared by x squared, you get a 1 here. Now let us multiply it, x squared plus x minus 6. Next you will change the sign, you remember that? So you will get a minus, minus, plus. Here 2 terms get cut. Normally that is not necessary actually. Now I get here plus 5. Now this is the remainder. So now let me write the x squared plus x minus 1 by x squared plus x minus 6 is equal to quotient plus remainder by divisor. Okay. Now if you look at the second part, that becomes a proper rational function. That is the purpose of division. So now let us write I will be equal to integral 1 plus 5 by, you know this can be factorized, so I will straight away write x plus 3 into x minus 2 dx. Now I can split it into 2 integrals. That is, the first part is 1 dx and the second part is plus 5 I will take outside. I will get 1 by x plus 3 into x minus 2 dx. Do you follow? Now, this is a normal partial fraction. You will write no a by b by and you will get the values of a and b, isn't it? Now I am going to teach you one shortcut for some sums, especially when you just have 2 distinct linear factors and especially when the x part is same, that is either both x or both 2x like that, very easily we can write it without actually performing that partial fraction method. I will tell you how to do. Now let me write this dx as it is plus 5. I am having a 1 here. Okay. Here I have the 2 factors x plus 3 and x minus 2. Now if I write the numerator as, just to see what happens, x and x will go. You will get plus 3 plus 2. So plus 5. But we only have a 1. To compensate, I can write 1 by 5 here. So now you will get a 1 in the numerator. That is, we have to make use of these 2 factors, either add or subtract, and you will get some constant. That constant if you divide, you will be getting 1. Okay. By x plus 3 into x minus 2 dx. Now, this I can now write as, the first part is dx. This 5 and that 5 will go. Here what will happen? X plus 3 by x plus 3 into x by 2. That x minus 2. That is nothing but 1 by x minus 2. In the second part, the x minus 2 will get cut. You will get 1 by x plus 3 then you will get a dx. Do you follow? I think this is simple enough, you can understand. If you think it is difficult, you can go for the normal a by b by. You can find your a and b and then you can split it into two things. Now here, for this it is x. For the first part, that will be log mod x minus 2. The second part is log mod x plus 3 plus c. You can combine these two. It is like log a minus log b. So let me write it as log of a by b plus c. Is it not simple? So here what is the first step? You should remember. Divide. Do the normal division. Then express the integrand as quotient plus remainder by divisor. Here always remember the remainder should be at least 1 degree less than the divisor. After that, you will get it as a partial fraction and then you have to proceed in the normal way which you already know. Is this sum clear to you? Let me do one more example. I is equal to integral x cube plus x plus 1 by x minus 1 dx. Here, the degree of the numerator is greater than the degree of the denominator. Same rule. So, first we are going to divide. Okay. So, now let me do the division. I will write x cube plus x plus 1. I am going to divide by x minus 1. First term by first term. So, I will get an x squared here. X squared into x will give me x cube. X squared into minus 1 will give minus x squared. Change the sign. X cube will get cut. Now there is no x squared here. So write plus x squared. Then write the other two terms also. Again the first term by first term. So x squared by x. That will give you x. X into x is x squared. X into minus 1 is minus x. Right? Change the sign again. X squared will get cut. You will get 2x plus 1. Till it is not over. Because your divisor is of first degree. Your remainder is also of first degree. I told you, you have to divide till your remainder is at least 1 degree less than that of the divisor. Okay. So now 2x by x, that gives you 2. So put 2 here. 2 into x, that will be 2x. 2 into minus 1, that will be minus 2. Change the sign. This will go, I will get a 3. Now the remainder is 1 degree less than the divisor. Okay. So now we can write this x cube, I will write here x cube plus x plus 1 by x minus 1 is quotient. That is x squared plus x plus 2. This is quotient. Okay. Plus remainder by divisor. Okay. Now let us go to I. Now I will write that is equal to, I will write the quotient part, x squared plus x plus 2 plus 3 by x minus 1 dx. You know, all the terms are easily integrable. Straight integration is possible. So now let us start integrating. X cube by 3 plus x squared by 2 plus 2x plus 3 log mod x minus 1 plus c. Okay. So once you know the way, that is first division, then expressing it as quotient plus remainder by divisor, then the rest is easy only. So hope you understand the two examples I have given you. Next we will do one special sum I can call. It is also partial fraction, but a bit lengthy, and a special sum I will call. That we will do. I is equal to integral x squared plus 1 into x squared plus 2 by x squared plus 3 into x squared plus 4 dx. The degree of the numerator is degree 4. Similarly, the degree of the denominator is also degree 4. So you know you have to divide. But if you have a fourth degree and do the division, that will become a very lengthy thing. So let me tell you some easy way of doing. Listen carefully. Let me write the integrand here, x squared plus 1 into x squared plus 2 by x squared plus 3 into x squared plus 4. Okay. Here I am going to substitute x squared is equal to t. This substitution is not for integration because I can't write anything for dx here. I am substituting only for the purpose of partial fraction and the simplification only. Then I will come back to the x before integrating. Okay, that is very important. So now I am going to substitute x squared is equal to t now here. So I will get it is t plus 1 into t plus 2 by t plus 3 into t plus 4. Let me call this as step 1. Right? Now this t plus 1 into t plus 2 is nothing but t square plus 3t plus 2. The denominator is t square plus 7t plus 12. Okay? Now both are of degree 2. So now I can divide and I can come to the quotient plus remainder by divisor format. Okay? Because I wanted to avoid that fourth degree. So now I have got a second degree. Now let me do the division. But everything from 1 only I am proceeding. Okay? So now I am going to now divide t square plus 3t plus 2. I will divide by t square plus 7t plus 12. So 1, because t square by t square gives you 1. So you will get here t square plus 7t plus 12. Change the sign, t square will get cut. You will get minus 4t minus 10. Now if you look at the remainder, that is 1 degree less than the divisor. So I can stop it. So now I can write this is equal to, in case that is that 1, okay, that will be now equal to remainder plus quotient plus remainder by divisor 70 plus 12, which I can write it as 1 minus I will take out. I will get 4t plus 10 by, this is t plus 4 into t plus 3. Right? That is, we can factorize the denominator as t plus 3 into t plus 4. So now this given integrand, which is equal to 1 and that 1 is equal to this. So we can call the given integrand is equal to this part. 1 minus 4t plus 10 by t plus 4 into t plus 3. This you can actually use partial fraction method and you can express it as a by t plus 4 plus b by t plus 3 and you can get the a and b, right? So this is also again 1 I will write. Now from that I will just take this part, then I will come back to 1 again. Now remember the notations carefully. The given sum in x squared, that is equal to this and that is equal to what we have done so far. So now I am going to just write 4t plus 10 by t plus 4 into t plus 3. You can write any one of the factor first, that doesn't matter. Okay. So this I will write, this is equal to a by t plus 4 plus b by t plus 3. Here and all the shortcut method will not help. Okay. Because I have a 4t plus 10, it's a bit difficult. So I am teaching you the normal way. So now here, when you take the LCM, you will be getting a into t plus 3 plus b into t plus 4 by t plus 4 into t plus 3. So the denominators are equal. So we can equate the numerators. You will get 4t plus 10, that is equal to a into t plus 3 plus b into t plus 4. You have two factors. So first you put t is equal to minus 3 in both the LHS as well as the RHS. So 4 into minus 3 will be minus 12 plus 10. So you will get minus 2. That will be equal to. This term will vanish. We will get the value of b straight away. So b into you will get 1, right? Because minus 3 plus 4. So the value of B is equal to minus 2. Then you write T is equal to minus 4. So here you will get minus 16 plus 6. So you will get a minus 6. Now the B term will vanish. I will get A into minus 4 plus 3. That gives me minus A. So now A will be equal to 6. So I got the values of A and B. So now I can write that 4t plus 10 by t plus 4 into t plus 3 is equal to A by, that is 6 by t plus 4 minus 2 by t plus 3. Okay. So this let me call as 2. Now I am going to substitute this 2 in the 1 here because I have a 1, I have a minus there. So now substitute 2 in 1. So what will you get now? You will get 1 minus, in bracket you will get 6 by t plus 4 minus 2 by 2 plus 3. Right? So now go to the beginning. So this one. Right? And that is equal to this one. So now let me come back to my x. So now I will write t is equal to x squared. I will go back because before the integration I have to definitely go back because all these algebra operations only I am using a substitution. So now I will get 1 minus 6 by x squared plus 4. Minus into minus becomes plus 2 by x squared plus 3. This becomes my 1 now. That is this left hand side. That will be equal to this one. Is it clear? So you have to properly organize your steps and give proper notation. Then only there won't be any confusion. So now actually this is the integrand and that is equal to this now. So now let me come to I, that is equal to integral 1 minus 6 by, I will write this as x squared plus 2 square plus 2 by, I will write x squared plus root 3 the whole square dx. You know everything is easily integrable, isn't it? So now I will integrate. For 1 I will get x minus 6. This is like x squared plus a square in the denominator. So it is 1 by a tan inverse x by a. Okay. Similarly for this one write the 2. 1 by a tan inverse x by a. Finally 1c. So here this and this will get cut. You will get a 3. So the final answer is x minus 3 tan inverse x by 2 plus 2 by root 3 tan inverse x by root 3 plus c. Do you understand this model? So this one is actually when you get in both the numerator and denominator x squared plus or minus some constants and both the numerator and denominator are of the same degree, you can use this concept and do the division. Then you can split it into partial fraction, then go back to the usual format and then you have to integrate only when it is in x. Okay. So it is not a normal substitution. This is a substitution for partial fraction alone. That you must be very clear. Hope this sum is clear to you. Now let us see how to integrate integral subtype. Integral dx by 1x here and then here x power n. It may be any power plus or minus some constant. Here you should have only x outside the bracket and here you can have x power anything plus or minus any constant. For that model what to do? Here you have to remember two things. The first is multiply the numerator and denominator by x power n minus 1. Whatever be the n, you have to multiply the numerator and denominator by x power n minus 1. Second step, substitute x power n is equal to t. If you remember these two, you will be able to do sums of this type. Now let us see one example. I is equal to integral dx by x into x power 5 plus 2. Here in the place of n you have 5, in the place of a you have 2. So n is 5. So now we have to multiply the numerator and denominator by x power 4. That is the x power n minus 1, correct? So now we will get x power 4 dx. Here x power 4 into x will give you x power 5 into x power 5 plus 2. Okay? Now we have to substitute x power n as t. So put x power 5 is equal to t. Now when you differentiate, what will you get? 5x power 4, that will be equal to dt by dx, or x power 4 dx is 1 by 5 dt. Because here we are putting this substitution for integration. So here we have to differentiate. So don't confuse it with the last model. So now I will get this x power 4 dx is 1 by 5. I will write outside dt by t into t plus 2. Now these factors will be simple enough. Without going for a by b by, we can easily write them using the shortcut I taught you. Now this is t plus 2. See, I will write 1 by 5 dt. Here the numerator I will write t plus 2 minus t. That is, I will use these two. What will I get? T and t will go, I will get 2. To compensate, I will write 1 by 2. Here I will get t into t plus 2 dt. Do you understand? Mostly, it will be like the bigger one, greater one minus the smaller one. Then whatever may be the constant, that you will be writing outside as 1 by. So now you will be getting 1 by 10 integral. First this by this, that is t plus 2 will go, you will get 1 by t. Then this by this. So the t and t will go, you will get t plus 2, then dt. Okay, it has become very simple. So 1 by 10 log mod t minus log mod t plus 2 plus c. This is like log a minus log b. You can write 1 by 10 log mod t by t plus 2 plus c. Now what is t now? That is x power 5. So the final answer is log mod x power 5 by x power 5 plus 2 plus. Do you understand, ma? This is an easier model only, isn't it? So just remember these two steps. So now actually we have finished the partial fractions method, or proper as well as improper, and a special model also I have taught you. With all these things I have taught till now, you will be able to do in the NCERT textbook up to exercise 7.5. Definitely you will be able to do all the sums. So you have to practice all the example sums and the exercise sums till that exercise 7.5. The ISC also, please refer the corresponding exercises in your textbook. Then in the next video, you will learn a different method of integration. Okay? Thanks for watching the video. Share it with your friends and classmates.